In this problem, we're asked to solve the absolute value equation and then write it in a solution set notation. As we examine this, we have the absolute value of 7 plus 2x plus 3 is equal to 8. Therefore, in order to solve this absolute value equation, one thing we can do is isolate that absolute value. Therefore, we could start by subtracting 3 from both sides of the equation. On the left-hand side, we will be left with the absolute value of 7 plus 2x is equal to 8 minus 3, or 5. Let's take a moment to recall what it means with the absolute value symbol. One way we can visualize the absolute value symbol is on a number line centered at 0. The absolute value, therefore, tells us the distance away the value is from 0. Therefore, we're looking for values of x that when we double it and add 7, that distance is equal to 5 units away from 0. That would tell us that 7 plus 2x is equal to 5, or we could have our expression 7 plus 2x being equal to negative 5, because that would also be 5 units away from 0. Therefore, we can see that we're going to come up with two solutions. Let's solve each one of those linear equations separately. In order to solve 7 plus 2x is equal to a negative 5, I could subtract 7 from both sides, giving us 2x is equal to a negative 5 minus 7, or a negative 12. Dividing both sides by 2, I can see that one solution is x is equal to a negative 12 divided by 2, or a negative 6. Or we can solve the second equation that 7 plus 2x is equal to 5. Again, we will subtract 7 from both sides, giving us 2x is equal to a negative 2. Dividing both sides by 2 results in x equaling a negative 1. Therefore, we have our two solutions, x is equal to negative 6, or x is equal to a negative 1. Before we are certain that those are our answers, let's just go back and verify it. We can substitute back in x equal to negative 6 or negative 1 into our original absolute value equation to make sure that our statement is true. So if x is equal to a negative 6, we would have the statement 7 plus 2 times a negative 6 in absolute value plus 3, and we want to verify that it's indeed equal to 8. Taking 2 times a negative 6 gives us a negative 12, so we have the absolute value of 7 plus a negative 12, and then we add on 3. 7 plus a negative 12 is a negative 5 plus 3, and an absolute value of a negative 5 is 5. Therefore, we have 5 plus 3 is indeed equal to 8, telling us that x is equaling to negative 6 is indeed a solution. We could do the same thing for x is equaling to a negative 1 to verify that it is indeed a second solution. Therefore, substituting in x equal to negative 1, we have the absolute value of 7 plus 2 times a negative 1. Then we add 3, and we want to verify again that that's equal to 8. 2 times a negative 1 is a negative 2. Therefore, we have the absolute value of 7 plus a negative 2. Then add 3. 7 plus a negative 2 is 5, so we have the absolute value of 5 plus 3, and that is indeed equal to 8, telling us that x equaling negative 1 is also a valid solution. Therefore, our two solutions are negative 6 and negative 1.